Today we're going to talk about starting and charging systems. Now there's a lot of things that could cause your vehicle not to start. So you go ahead and whether you got a key type of ignition switch or whether you got a push button, some of the stuff we're not going to address in great detail in this video. Stuff along the lines of what happens if it's a security system problem. This car definitely just needs a battery, as we're going to find out here. But if you had a vehicle that didn't want to start, little telltale signs, you can see if the security lights illuminated or flashing on the dash. All of that security system is going to be covered more in depth in an upcoming key programming video that we're going to release here on YouTube. However, for this video, we've already scanned. There's no types of trouble codes in this vehicle or anything, but it is cold here in Ohio, which is where I'm from. And in the two weather extremities, whether it's really hot or really cold, that's when batteries have a tendency to fail. Now this happens to be a 2019 Buick Encore. It's got the factory battery in it, so it's 2024 now, so it's about due for a battery. But we're going to talk about how we go about doing different types of tests on the battery starting and charging system. So there's two different types of battery testers out on the market. One is what's called a carbon pile style load tester. What this tool does is it actually applies a short across the positive and negative battery cables. Now I do have a brand new battery that we're going to be replacing in here. I'm not going to show you the whole replacement process, but I'll show you what you have to do as far as registering the battery and stuff after it's been installed. But this one is going to create a short across a positive and negative battery terminal. The more I crank this knob, the bigger the short becomes. And that's how we're going to load test the battery. The drawback to this style is it's great for testing batteries. There are some more expensive units. I got this one from Harbor Freight. There are some more expensive units on the market that actually have an inductive amp clamp as part of the unit. With this one here though, it's relatively more affordable for the do-it-yourselfer. I will have to use an inductive amp clamp to test the charging system, and if I wanted to do starter current draw, I'd have to use a voltmeter with a separate inductive amp clamp. Now the other style battery tester that's out on the market is what we call a conductance style, and the difference between this style and this style is this one will not create a short across a battery. It's safer for modern day computer controls. It has special leads on it which will actually go ahead and send a little bit of a current through these leads and pass that current along the plates of the battery so that it can actually do a simulated type of load on the actual battery itself to determine whether or not the battery is good or bad. So with all that being said, one of the first steps you want to know is how do I go about using something like this? So I will start with the carbon pile load tester. I would just take the two red and black clamps. I'm going to find the battery wherever it's located on the car, and this one's nice because it's under the hood and it's relatively easy to get to. I'm going to go ahead and hook up the positive clamp to the positive post here, make a good connection, the negative one to the negative post, and as soon as I do that, the fan comes on inside the unit because it's going to want to install or provide a short across those two terminals as I start turning this knob. Now this particular unit can test 6 volt, 12 volt, and 24 volt batteries. So whether you're dealing with, heavy duty trucks or whether you're dealing with lawn and garden equipment, doesn't much matter. On the top of every battery is going to be a sticker. And it's going to have all kinds of terminology on it, all kinds of ratings. What we're looking for is the cold cranking amps, CCA, and it says on this particular one it's 650 cold cranking amps. On the one that's in the car is 525. So to test this battery, what I'd want to do is I'd want to make sure that it's fully charged. So I'm reading 12 volts over here. It's telling me it's okay to test. If it was lower, maybe I had a charging system problem, or maybe the battery was just failing, way worse than the one that's in the car now. I want to go ahead and charge that battery up to get a valid test. Now this one I don't have to do that. I can just go ahead and apply the load. Now, what I'm going to do is I'm going to take that cold cranking amp loads, I'm going to use the 525 as an example, I'm going to cut that in half. So 525 in half is roughly, let's say, about 260 or so cold cranking amps. So I'm going to dial this knob in until I get to about 260 over here, and I want to leave it on there for 15 seconds. So I'm going to start cranking this down. We're about 260-ish now. And the rule of thumb is it should not drop below 9.6 volts during that 15 seconds time. Now we can see it's got a little audible alert that's telling me, hey, you left it on too long. It dropped well below the 9 volts. So this explains why, even though this vehicle still starts, if it's relatively warm outside on a really cold day or a cold wind chill, it doesn't want to crank very fast. Now I do a lot of traveling for training for my day job and stuff, and a lot of times this car is parked in an airport parking garage, and I'm always fearful when I come back from my trip, go out to the garage, hey, if it's cold out, is it going to actually crank over and start? So they keep me pretty busy in my day job. I don't have a whole lot of time to be replacing the battery, but this time I figured, well, I'm going to replace the battery here today. So that's one of the quick things that we want to do. Now, another thing we can do, I'll show you how to do the actual conductance style tester here in a second. But another thing we'd want to do is we'd want to test the charging system on this car. We want to make sure that that's working properly. Now, if you had a more expensive unit like this, you could do that by just taking the inductive amp clamp that would be part of the unit and actually clamping it around, and you'd actually start the car. Now, starting the car, you'd want to watch the actual battery voltage gauge, plus you'd want to watch the amperage gauge. So this is the voltage gauge, this is the amperage gauge, because that starter current draw is going to put a load, probably the biggest load that your vehicle would have on there. You want to make sure that under those loaded conditions that I don't drop too much either. And then once it starts, now the engine's running, the alternator's turning over. Now I'd want to turn a bunch of loads on the vehicle and actually see if the alternator is capable of charging up the battery. So what I'm going to do is I'm just going to focus our attention over to this little guy now. And what I did is I've got a high amp inductive current clamp. So here's the difference between a low amp and a high amp. Obviously the hole inside of it. And I want to clamp around both of either the positive or negative battery cable. So with that being said, I'm going to turn my clamp on here. I'm going to go on the 400 amp scale. I'm going to push the 0 button just to get my meter to 0. And by clamping around both those cables, this is what I mean by that. A lot of times on a modern day car, we'll have the big heavy duty battery cable, but then there's going to be a secondary cable around it as well. Positive one's a lot harder to get to on this particular car. It's got this red plastic thing with the fuses and all that stuff in it. So I'm going to choose the negative, and I'm going to make sure I have both of those leads clamped in there well. So if I got to yank on the leads or whatever I got to do, I want to make sure that that clamp is in the closed position there. Now technically, I've got this so that I'm on the volt scale, even though I'm going to be measuring amps. That's what the inductive current probes actually do, is they convert the voltage that it's picking up in here, and they're going to display it on the voltage scale, but it's actually going to be represented as amps. So I'm going to start the car up. I'm going to turn on a bunch of loads inside the car, and I'm going to get some type of alternator output reading here. So I'm going to go on over to the car. I'm just going to sit inside of it, start it up. Now I'd want to raise the RPM up to make that alternator work a little bit harder. The downside to doing this test like this is there's only so many loads I can turn on inside the vehicle that's going to give me a stable reading. If I turned on the turn signals or the hazards, that load is coming and going, so that reading would want to jump all around. If I happen to have this old-fashioned carbon pile load tester, I can actually go ahead and give it a little bit more of a load and get a little bit more accurate reading of this alternator output. So I'm only going to go ahead and, I'm not doing the whole half of cold cranking amps. I'm just going to go ahead and give it let's say about a 60 amp or so load. And we can kind of see that the amperage that it's pulling out here is coming up, and it's telling me that the alternator itself on this vehicle is capable of charging. So I don't think I have a problem with the actual alternator. Now I'm going to shut this off, and I'm going to show one more thing. I'm going to show one more thing before I switch over to the conductance style, which will give me a self-guided test menu. So I'll take these out of the way. And another common thing that happens on starting and charging system type of complaints is I might have a battery drain. So there's a lot of ways we could test for battery drains. Now, normally what I would do is I would not use the way I'm about to show you, because on a modern day car, if I go ahead and disconnect the battery cable, I might be resetting a bunch of monitors on the car for OBD2. I might have to relearn the minimum airflow rate. There's a lot of scenarios that could happen. So I could take my digital voltometer, I could go to the fuse boxes. There's multiple fuse boxes on any modern day car, and I could do a voltage drop across each one of the fuses. That's one way that I would do it. Another way that I would do it normally would be to take my low amp current probe and do the same type of scenario, clamp around the feed wire to the fuse boxes, and I would get a reading that's telling me how many amps are being drawn when the car's in the off position. Anything that's drawing amperage, there's always going to be some stuff like the radio station memories. In order to keep its memory alive, there's got to be a small amount of current draw on the battery. However, if you let your car sit overnight and it doesn't want to crank, or if you let it sit for 2 days, 3 days, 4 days, whatever, if the scenario I use, I go out of town for a week, I come back to the airport, I expect my car to start. If I had something that was drawing too much current when the vehicle was in the off position, it could be the network comes back alive on a modern day car. Whatever the case happens to be, I'd want to be able to check that. So one quick way I can do that with a meter like this is the way we did it for years, is I would disconnect either the positive or negative cable. It's always safer to disconnect the negative. So I disconnect the negative cable, go ahead and pull that cable off. Now, at this point, I would take 2 leads from my meter and I would hook them up to the actual device here, and I would go ahead and put my black lead in common and my red lead in the capital A. Now, hopefully we don't have, 1 amp or more of a current draw on here, but I always want to start in the capital A, because the way these meters work is there's going to be 2 fuses in most meters. The fluke fuses are very expensive. They're about $7 a piece. So if I happen to have a large amperage draw, the 10 amp fuse is going to be well more protected than the 1 amp fuse in the milliamp side. So I can always switch the jack at a later point. But at this point, I would turn my meter onto amperage DC, and I would just hook one of the leads up to the cable and one of the leads up to the post that I just connected. I'd give it a couple seconds to stabilize here. When I first hooked it up, remember we got communication systems and stuff, so we're going to get that large amperage draw, but we can see that this amperage draw is well within the acceptable readings here. So this is a quick, easy way I can do it. At this point, I proved to myself that, hey, it would be safe for me to take this out of the capital A and put it in the milliamp one. But I don't ever do that when I'm working on vehicles. The only reason being is if I have this hooked up right now and I walked over to the car, forgetting I have it hooked up like this, and I open up the driver's door, that dome light's going to want to turn on. And that dome light's going to draw a lot of current by itself, and I might end up blowing the fuse. So I always leave it in the amperage scale, and I can read this down. And we got, it's still dropping. So we're dealing with less than 10 milliamps at this point, because it's going to continue to keep dropping down here. So I'm not too worried about any type of current draw that's on there. Another old timer's trick is if I go ahead and hook my cable back up and I saw a big spark or an arc occurring, Well, that's a good sign that there is some type of current draw on there. That's going to be a pretty heavy current draw, which is going to force me to definitely want to do this type of test. Now, what I'm going to do is I'm going to do the same type of scenario here, but I'm going to show you the difference between the old-fashioned style testers and one of the conductance style testers. So I'm just going to hook this back up, and like I said, this battery we already know I'm going to have to change. So I'm not too concerned about, hooking the battery back up for the time being, any of those things. So I'm going to take my conductance style battery load tester here. I'm going to power it up, and this one's made by Autel. I'm going to go ahead and clamp around the negative and positive battery cables, and I got a couple choices. I can either do an out-of-vehicle test or an in-vehicle test. So we're going to go ahead and do both. Even though it's in the vehicle, I'm going to simulate that it was out of the vehicle, and I'm just going to select that first. It's going to be very similar to what we just did. One of the nice things is, before I don't have to worry about any kind of switches or anything like on the carbon pile test, it asks me, what am I working on here? Am I working on a boat battery, a lawnmower battery, whatever? Obviously, we're doing automobile, so I'm going to select automobile. It's going to say what type of battery you're working on. Now, I'm going to scroll up. This is a flooded style battery, but here's my choices that I have. AGM, got to be in the right column. AGM spiral. So I got quite a few. I got gel. There's also a lithium style battery that I can choose from the main menu, which is very common in mild hybrid systems. So I can't test a lithium battery with the old-fashioned carbon pile load tester. Also, the carbon pile load tester, they say, is not as safe for modern day computer controls, but it does actually create a heavier short on here. Now, in the second column, it asks me what type of testing I want to do. I'm going to select CCA from the list. Remember, that sticker that's on the battery will give me the SAE reading, the cranking amp reading. I'm going to select cold cranking amps because that's what we used before. It's 525, the one that's still currently in the vehicle. So I'm going to scroll on down to 525, and I'm going to say next. And what's nice about this tool is I can have the ability to create a report. So at this screen, I can go ahead and add pictures. If there was a lot of corrosion around the terminals, or maybe if the hold down was missing, or the battery was damaged, or whatever type of picture I wanted to add, I could add it, which would then end up being displayed in the final report. I'm not going to create a report for here. I'm just going to say start testing. And because we lied to it and said it's out of the vehicle, it's going to stop after this test because it's just going to do a battery test. It says 100%. Now, there was a surface charge on it because we just had it running, but even here it comes up and it says replace the battery. So at this point, I can actually save this and create the report off of it. All of this I could then go ahead and print out. This one has a built-in printer. Some of the other units don't have a built-in printer, but you could send it to the cloud. And at the cloud, then you could print it out. You can email it to the customer. You could do whatever you wanted to do. But I'm going to back up out of here now. And we're going to do it a little bit different way. I'm going to go all the way back to the beginning. Here's where the lithium battery test would come in. That's going to be for mild hybrid systems. I'm going to go with an in-vehicle test. Now, the big difference between in-vehicle and out-of-vehicle is it's going to prompt me to go into the starting and charging system test after it tests the battery. So again, I'm going to select automobile. It's going to tell me, hey, since this is a later model car, I got to plug in the VCI. Now, the VCI is going to go into the OBD2 test port. So I'm going to go inside the car real quick, plug this in. It gives me common locations for that. I know where it is. This happens to be my personal car, so I don't need to look at where the common locations happen to be. I come back over. Now that I got that plugged in, I'm going to say OK, next, and I'm just going to follow the directions on the screen. So it's going to ask me some information about the vehicle. I don't necessarily have to put all of those fields in. I do have to tell it a little bit of stuff here. So I'm going to tell it it's a 2009, well, I'm going to tell it it's a Buick, first of all. So I go on up, say Buick. Then I'm going to say it's a 2019. It automatically pulled the VIN on a late model car, so I don't have to go through that. Told me it's an Encore. Anything else I wanted to do, I don't have to worry about it. So I'm going to go ahead and say this one's got a 525 cold cranking amps here. So I'll scroll this back down. And I'm going to say, okay, it also would tell me where the battery location is. If I opened the hood and I couldn't see the battery, because it has the ability to pull the VIN, it knows where the battery location would be. Now again, I get to the same screen. I could add pictures if I wanted to. I don't want to, so I'm just going to say next. It tells me to turn off the electrical appliances, ignition off, close all the vehicle doors. We did all that. We're going to say start testing. Oh, I got to check those first. Then I'm going to say start testing. Now it's testing the battery by itself. Has the battery been charged before the test? It hasn't, so it may want to come back and tell us, hey, let's go ahead and charge the battery first and let's redo the test because the voltage is so low. But I already know that this has a bad battery, so, and technically we did run the car, which did put a little bit of a charge back into it. So I'm just going to say yes. This way it doesn't tell me to charge it and then come back and retest it. So it tells me I got to replace the battery here. So at the bottom of the screen, I got a couple things here. I can either choose to replace the battery, create a report, or go ahead and hit the continue button. I'm going to go ahead and hit the continue button. And now it's going to continue on with more testing. So starter test is going to be what it's going to want to test next. Ensure that the ignition is off. I'm going to hit the check mark. I'm going to say start testing. Now it's telling me wait for the vehicle to start, which means I have to go inside the vehicle and start the car up. Told me the starting voltage was 11.40. The actual starting time took 1.26 seconds. I'm going to hit the continue button again. Told me the overall test result was the cranking was normal. I'm going to hit continue again here. Turn off electrical appliances such as headlamps, AC, press continue. So I'm going to turn those off. Hit the continue button, let it do its thing here. Now it's telling me to keep the engine speed at about 2,000 to 3,000 RPM and press continue. I'm going to go ahead and do that because eventually it's going to tell me to turn some loads on. So I'm going to go ahead and hit the continue button right now. It wants to see me hit that 2,000 RPM. Then it's going to tell me to turn some loads on. Turn on electrical appliances. I have to hit the OK button, so I got to go back in the car, raise up the RPM again. Going to come back out, turn off the ignition, electrical appliances, and press continue. So I'm going to turn off the ignition. So normally we would do this with this sitting in the driver's seat with me so I could actually read all of it. But it comes out and tells me the finished result here that the charging is normal on this car. So in essence, There's not a problem with the starting or charging system. There's just a problem with the actual battery. Now you might be saying to yourself, well, what about that whole amp clamp thing you were talking about before? I can still do it. That little noise is telling me, don't forget I've got a VCI plugged in underneath the dash. I can still do that with this tool. If I buy the battery accessory kit, so BAK, and I plug in the module at the bottom of this unit here, I now have the ability to turn this tool into an enhanced testing tool. So I've got the little module, and I can either plug in, volt and ohm meter leads at the bottom. I can come with the high amp current probe at the bottom here, and I can do a whole bunch of more testing. So if I scroll on over to multimeter and select multimeter, it asks me for a couple different things that I might want to do. Do I want to do a leakage detection? This would be any type of parasitic drain on the battery, something that's going to cause it to die over time. Or would I like to use basic functions? If I go into basic functions, it comes up and it gives me a screen, tells me how to hook everything up. We're going to say, okay, we're good with that. We understand what we're doing. And now I have a graphing meter at my disposal here. So I can either tell it I want to test voltage or amperage. So if it was voltage, I just hook up the 1-to-1 leads at the bottom, and I can do an actual voltage test on it. So I'll just simulate that real quick. I'll take these two leads just so you can kind of see how that looks. And I'll plug these leads into the bottom of the actual module here. And I'm just going to touch the battery cables here. So now it's telling me I got about 12.63 volts. And it's a steady voltage because it is just a battery, so it's going to be a straight line. But I could use this same type of tool to do the individual test. If I wanted to measure if there was some type of amperage draw, I could take a cable off. I could use it as an amp meter. I could do a cranking compression test with this tool. And again, all of this stuff could be saved to a report. I can also use the built-in printer to have a printout so I can hand something to the customer. But what I want to do is I'm going to go back to the home menu here. And before we get too far ahead of ourselves, I'm going to go back over here, and it says battery reset. So after I'm done changing the battery on this vehicle, I'm going to do that off camera. We'll come back with the new battery in there. We can quickly test the battery again, but I'm going to want to tell the car's computer, since it's a late model car with smart charging system, that I put a new battery in it. If I don't do that step, whether manufacturers want to call it battery registration, or in this one, battery reset, the car's computer will eventually start charging the proper current again to the battery. But for all this time, it knew it had a weak battery, and it was charging at a higher rate to accommodate that weak battery. So if I just put a new battery in that is not weak, in theory, I'm going to be overcharging that battery, which is going to cause the battery to fail prematurely. So after I change this battery out, we'll come back in, we'll tell it that we put a new battery in. We're going to basically, whether you want to call it battery registration or battery reset, and we'll be able to pick up and do the same test again, and this time we should have all thumbs up saying there's not a problem. So I'll see you in a second. Okay, so I changed out the battery in here. I made sure the battery connectors are clean, made sure the hold down was in place and all that. So what I'm going to do is I'm just going to do a quick little test of the new battery. I've already tested it. I know it passes. Again, I'm going to lie to it. I already did the in-car testing of the starter system and also the charging system, so I don't really care about that. So I'm going to lie to it, tell it it's an out-of-vehicle test. Again, I'm going to select automobile. This time, however, it's same type of battery, but this is a little bit bigger of a battery. I always like to have a bigger battery when I replace the factory one. This one is 650 cold cranking amps. I'm going to say next. I don't care about adding any pictures to the report or anything, so I'm just going to do start testing. The battery test is in progress. We're already at 90%. It's finishing up the test now, and it tells me the test results are it is a good battery. So I know, I always test the battery before I put it in the car, but I just wanted to show this on film that this is what the good test result would actually look like. Again, I don't care much about creating a report because this is my own personal vehicle, so I'm not going to send myself an email with a report or anything along those lines. Now, at this point, what I'm going to do is I'm going to tell it that I've put a battery in the vehicle. So I'm going to hit the battery reset button. It wants to decode the VIN. So it comes up, it tells me everything about it. I'm going to say, yeah, all this stuff looks good to me. I'm just going to hit the little X button to get out of here. I put in a different battery. I'm going to say next. It wants to register that I put a battery in. I'm going to say okay. I'm going to do auto registration after battery replacement. Was the power disconnected during the battery replacement? The answer is yes. It tells me, this is a very important step of this tool, or most tools that are made like this, is it tells me what I'm going to have to do. So, there's a lot of learning procedures that every car line is going to be a little bit different. So it's going to tell me I got to turn the ignition to the on position, fully open the window, the driver's side window, fully close the window, and long press close switch for 5 seconds, then release the switch. So I'm going to go inside the car here. I'm going to do everything that it told me to do. So I'm going to turn the ignition on. Okay, I'm going to fully open the window. Then I'm going to fully close the window. Then I'm going to long press the switch for 5 seconds. So I did that. Say this is about 3, 4, 5 seconds now. And again, most of the time I'd be doing this with the unit held in my hand, so I didn't have to keep getting in and out of the car, but for sake of the video here, we're good to go. I'm going to hit the finish button. I don't have a sunroof, so I don't have to worry about resetting the sunroof at this point. I'm going to say okay. And at this point, I just finished the whole procedure. The car's computer system now knows that there's a new battery put inside the vehicle, so I don't have to worry about, when I first start this vehicle up, for the computer to take time to stop technically overcharging the battery, thinking it's still the weaker battery. So it's a pretty simple thing. Every one of those steps for registration are going to be different on different types of cars, which is why it's important to have a quality, conductance style battery load tester for late model cars, so that you make sure you do those procedures correctly without having to, spend a bunch of money on an information system to get those little steps that are required to allow the computer to know that the vehicle is now in learning mode. You put a new battery in, now it's out of learning mode and you're good to go. So this was a real quick little starting and charging type of video. Again, we didn't cover every single thing. There wasn't a problem with the alternator system. There wasn't a problem with the charging system. We will get a little bit more in depth when we go through a communications and key programming and security system stuff. We got plenty of videos in the hopper in our minds that we want to share with all of our faithful viewers here on YouTube. But this is a real quick way to have you understand the difference in the different types of battery testing tools that are on the market and what it takes to actually replace a battery, test a battery, replace a battery, and actually perform the reset afterwards on a late model vehicle. So again, this has been John. I look forward to seeing you in the next video. Thanks.